Okay, good afternoon, guys. I was reading chapter 4, and if you can do this worksheet for the most part, you should be able to be prepared for that chapter 4. Okay, everything is summarizing here. So for the first one, right, they want you to find the value of y. So this is going to be just 2, right? Because you can write 5 to this. Let me do that here. So that's going to be the same as 5 squared, right? You rewrite the logarithm as an exponential function, like a loop. So that's going to be 5 to the y equals 25. So you have to make the basis the same, right? So y equals 2. Okay. So here is going to be 0. I know. So this is going to be 3 to the y equals 1. So 3 to the y, if I make the same base, it's going to be 3 to the 0. So y equals 0, right? That's how you do number 2. You have to do the loop again, right? That loop like this. 3 to the y equals 1. Okay. This one. This is going to be negative 2. I know. So if you don't know how to do it, you can do the loop, right? You can do it like this. So this is going to be 16 to the y equals 4. So you can make the bases the same, right? So this is going to be 4. Yeah, 16 to the y equals 4. So this is 4, 2 to the y equals 4. Then this is to the power of 1, so 2y equals 1 divided by 2. That's going to be 1/2, right? Or, oh, sorry, I said 2, negative 2. That's going to be 1/2, sorry. So that's 1/2, okay? So you can do like that, okay? So if you don't know at any point, you can do that loop. So here the same thing, right? So this is going to be negative 3. So this is going to be 2 to the y to the 1/8, which is the same as 2 to the y to the 2 to the, let me do step by step, 2 to the third. So 2 to the y equals 2 to the negative 3. So y equals negative 3, right? Okay. Next one is 0, right? Because 5 to the 0 is y, right? So, I'm sorry, it's 5 to the y equals 1. So you can say 5 to the y equals 5 to the 0 because any number to the 0 is 1, right? And you have to make the same basis. So y equals 0, right? Okay. Here is going to be 3. So this is 2 to the y equals a. 2 to the y equals 2 to the third. Y equals 3, right? That's number 6. Number 7 should be negative 1. So 7 to the y equals 1/7. 7 to the y equals 7 to the negative 1. So y equals negative 1, right? So that was number 7. Number 8, I have, should be negative 2, right? So 3 to the y equals 1/9. 3 to the y should be 1/3 squared. 3 to the y is 3 to the negative 2. So y equals negative 2, right? That's how you do that. That was number 8. Number 9. So you need to do y to the 5 equals 32. So now you need to find the base. So you can do the 5th root, right? You can do 1/5, right? Or the 5th root here, right? But you know that that's 2 anyway. So y is going to be the 5th root of 32. So you can see, right? 32 is 16 and 2. And then this is 2 to the 4. This 16 is 2 to the 4. With this 2 to the 1 is going to be 2 to the 5. So then you have 2 to the 5. And then this cancels out. So you get 2, right? But you could see that from before. 10. That's going to be 9 to the negative 1/2 equals y. So basically this is what? 1 over square root of, well, let me do step by step. 9 to the 1/2 equals y. 1, this I can rewrite. 9 to the 1/2 is the same. Remember, this index is, this denominator is your index in the square root, right? Remember? But we don't need to put it. So that's going to be 1/3. Okay? That was number 9. So the answer is for, I'm sorry, number 10. The answer for number 10 is 1/3. And then 11, same thing, right? We have to do that loop. So 4 to the y equals 1/8. this is 2 to the 2 to the y, right? And this is going to be 1/8 is the same as 1/2 cubed. So this is going to be 2 to the -3. So y equals -3/2. Okay, that's the answer for 11. 12. Same thing, right? The loop. So 9 to the y equals 1/9 to the second power. That's 81. So 9 to the y equals 9 to the -2. So y equals to -2. So that's the answer for 12. So that's how you do that. Okay. Let me erase these things. So you know that this is just basic properties of logarithms, right? You know the logarithm of 1 gives you 0, right? Log any base of 1 is always 0. That's the property. So log AA, I told you too many times, this is equal to 1, so this is also 1. Here you can use the power rule, move this to the front, right? So this is 3 log 7, that's going to be 1. 3 times 1 is 3. And this one is b log b. This is like the inverse of this property. But anyway, if you see b to the base of b to the logarithm of the same base, that's just going to be the number 3. Okay. And then here we have log 25 of this, right? So you can think about this one. You can say log 25. You can do too many things here. Since this is 5 to the third, you can do log 25, base 25. You can do 5 squared times 5, right? That's the same as 5 to the third. And you can do log 25. But anyway, you will get stuck with this, right? So you don't want to do that. I mean, you can continue doing this thing, but let me make it simple for you. So let's say, let's make it easy for you. Let me see if I see the next number. Okay. Let's see. Let's make it easy. Log 25. So we have 5. Okay, so you can say that this is. Okay, we can move this number to the front. Okay, so we can say 3 log 25. And you may say, what happened? How can I simplify this? So you can do this. Log 325. Square root of 25 is 5, right? So that means that I can write this as to the 25 to the 1/2. And now you can move that one more time. So that's going to be 3/2 log 25. That's going to be 1. So the answer is 3/2. Right? I can do that. So I moved the 3 to the front, and then I did log 25, 5. That's what I have, right? But I know that square root of 25 is the same as 5. So then I can move this. Instead of writing square root of 25, I write it as 1/2. Then I move that to the front again, right? I move it to the front again, and I have 3/2 log AA, right? Log AA, you know, by definition is 1. So that's the reason this turns to 1 and this is 3/2. So that's the answer. Next. So here we have this property. We have 16 to the 4 to the 8. We need to simplify. So you can write this as 4 squared log 4 of 8. So now you can move this to the top, right? Here. So you have 4 log base 4, 8 to the second power. So if you have this situation, you know that that's going to be 4 to the log of the same number is going to be just 1, or basically whatever left over is just this guy, right? 64. So that's the answer. Because this will vanish, right? So it's just 64. Okay. So here they want you to write in terms of x. So they don't want x to the second power or square roots or whatever. So here this is the product rule, right? So you have the product rule. So you have to do log x squared plus log y, right? And then this is going to be, move this to the front. So that's going to be 2 log x plus log y. That's it, right? Now, next one. I'm going to put them here because I don't have a space. So for the second one, number 2, I have a division and I have a quotient, right? So I can say log x cubed. Since these are multiplying each other, the numerator, right? I'm just going to add it. So log x3 log y2 minus log c. So that's going to be 3 log x plus 2 log y. I'm using the power rule. And then this is log c. That's it. I'm done. That was number 2. Okay, number 3. We have, again, we have this log of square root of x times cube root of y squared over c to the 4th. So I'm going to put this log as x to the 1/2 because that's equivalent to a square root times, well, I can do plus right away. Plus, let's do step by step. Log plus log, and we have cube root of y to the 2nd power. So that's going to be the same as y2 to the 3rd, right? So I'm going to do log y 2/3. That's plus, and minus log c4 because that's the quotient, right? Now you can expand this saying log 1/2 log of x plus 2/3 log of y minus 4 log of c. So now I have everything in terms of x, y, and z, right? So that was number 3. So we did this, we did this, we did that. Okay. Number 4, I can do it here. So this is just log x plus log y plus log c, right? We can do that here. Next, this is a quotient and I have a product. So this is log x minus log y plus log c. So that means that this is going to be log x minus log y minus log c. Okay, that's the answer for this problem, 5. Okay, so we just did this, we did this thing too. Okay, that's how you do that. Next number, 6. I'm going to erase this because I need space. 6. So here we have log, so we can put this to the front, right? So that's going to be negative log 2x minus 2 log y, right? Because we have to distribute that too. In reality, it becomes like this, log x minus log of y, and then you need to distribute that to 2 log x minus 2 log y, right? Next, this one is 1/3 log x plus 1/3 log y. Same story like the previous one, right? Same story. Here I have log x plus log c to the 1/2 because c to the 1/2, remember this 2 is the denominator and there's not exponent to the 1st power, so that's going to be my numerator. Okay, so now I need to put it to the front, log x. I need to use the power rule, so this is 1/2 log c. Okay, that's number 8. Number 9, I have a quotient, so this is going to be subtraction. Log x, remember the cube root of x is the same as 1/3 minus log, now I have to be careful here, yc to the 1/3 here, right? 1/3. So now 1/3, I use the power rule, minus 1/3, and now I have log y. Let's put this in parentheses so I know that I have to do this, okay? So let's put that here. So this is going to be 1/3 log y plus log c, right? And we need to continue. So this is 1/3 log x minus, well, this times that, this times this is 1/3 log y, but it's negative, right? Minus 1/3 log y. And this one times this one is 1/3 log c, but the negative from the outside, right? It's going to be negative 1/3 log c. Okay, so that's the final answer for number 9. Okay, number 10. Number 10, we can write this as log x cubed y squared c to the 4 to the 1/4. So we need to do 1/4 using the power rule. 1/4 log x cubed y squared minus log c to the 4, right? And now we need to, this is yc to the 4, okay? Yc to the 4. Now we need to expand this. So this is 1/4 multiplying, we have a product, so we can write as a sum. Log x cubed plus log y squared minus, I'm gonna move this exponent to the front. So that's gonna be 4 log c, right? So now I need to do the same thing for the x and for the y. So 3 log x plus 2 log y minus 4 log c times 1/4, that is multiplying outside. So that's gonna be 3/4 log x plus 1/2 log y minus log c, right? Because -4 times 4 is just -1. So that's the answer for that one. That was number 10. Okay. Number 11, log x times x to the 1/2 over c, right? And everything to the 1/2. So we have a product, right? So we can write log x plus log, we can, yeah. So we can write this as log 1/2 c to the 1/2. Now we can say this is log x plus 1/2 log log x 1/2 log x. This is going to be x to the 1/2 over c. Now we can write this as a quotient. So this is going to be log x plus 1/2 log. Remember that 1/2 is multiplying everything, right? 1/2 log x to the 1/2 minus log c. Okay, and this is going to be log x plus 1/2 log, well, this 1/2 is going to move again to the front, so it's going to be 1/4 this time. 1/4 log x, and then we have log c, right? So that's going to be nearly 1/2 log c. So that's the answer for this problem. Okay, log times x to the all that. We have to use the power rule, right? Or you can use your exponents rules first, right? And it should be the same. Try after that. So here we have what? This one. So we can write this as x, y squared, c8, and everything to the 1/2. So that's going to be 1/2 log, all these things, right? 1/2 times this log. So we have x, y squared, right? Yeah, the 1/2 log of this thing, right? So in this case, I'm gonna write, because I moved the 1/2 already, I can write this as a product, right? Let me do step by step. So 1/2 and then minus log c8, okay? Now you have 1/2 parentheses, you have a product, so that's gonna be a sum, log x plus log y squared minus, I'm gonna move this a to the front, so that's gonna be a log c. Okay, so now here log x plus same thing, right? Move to the front, 2 log y minus a log c, and remember you need to multiply by that 1/2, so that's gonna be 1/2 log x plus 2 log y, actually 1, right? Because 2 times 1/2 is just 1, and minus 4 log c. Okay, that's that one. Okay, let's continue doing these things. Here, they want you to write an exponential form. You know how to do that. 3 to the 4 equals 81, just the loop, right? Well, this 7 to the 1 equals 7. Again, the loop. then this is what? 1/2 to the 3 equals, what is it? 1/2 to the 3 equals 1/8, right? And that makes sense. And this one, 3 to the 0 is 1. Then here we have to do 4 to the -3 is 1/64. 6 to the -2 equals 1/36. X to the C equals Y. M to the 1/2 equals M. And that's it. Okay? Let's continue. There's a lot to do here. Write the following equalities in logarithm form. So if now it's backwards. So you know that this is the base. So you put the base, log base 8, the number, which is 64, equals to 2, the exponent. A logarithm is an exponent. So the exponent should be the answer, basically, right? So we have log base 10 of the number, how many zeros are 4, equals 3, right? Here, log base 4 of 1/16 equals -2. Log base 3, 1/81 equals -3, right? That makes sense. Actually, 84, sorry. Here we have log base 1/2 of 32 equals 85. Then we have log 1/3, 27 equals 83. Log base x of y equals 2c. Log square root of x. Okay, so here they want to trick you. So just write this as 1/2 and y. So this is log base x of y equals 1/2. Okay. Now, true or false. So this is kind of like the questions that we have on the test, on the review of the test, right? So let's see. So here I have to do, this is log x minus log y to the third. You move this to the front and you're gonna get 3 log x minus 3 log y, which is true, right? Next, log a minus b. So this is not true because this is supposed, if we don't have a rule for this one, right? The rule for this one is that this is log of the same base a over b, which is different than this. So this is false. And this is true. Okay. Next. Here they have log x to the k. Notice the position though. You see the k? So it's not like the one in the test that they have like this, right? That's not equal to k log x. That would be wrong. It's not like that. So this one is k log x. So this is true. Okay, next. So we have log a, there's no such a thing rule for this in logarithms. And there's no such a thing as this. So this is nothing. So this is false. Okay. If it was like this, log AB, we know that that's log A plus log B. But I cannot factor the log like this way, okay? This is false. Okay, what about this one? This is false too, because you know that this is what? This is the log, this is your denominator, and this is A. It's not this, right? That's not that. So this quotient becomes this, not that. So this is false. Next. No, you know, now this is what I was telling you. This is not this thing. This is not this thing. This is very false. Okay. Like this is true, the one from here, right? But this is false. Be careful when you have that. Okay. Okay. Now here, you know that this is 1, right? This you can use a power rule. So this is going to be log A. You know that log A is just 1. So A times 1 equals to A. So that's the same as this one. So this is true. What about this one? So I can move the negative to the top, right? So I have ln 1 over x to the negative 1 equals ln x. So if you apply this, x to the negative 1, that's going to be ln 1 to the negative 1 if you want to do it that way. X to the negative 1. 1 to the negative 1 is 1 here, and x to the negative 1 is x. So that's going to be just log ln x, right? So that's true. So this is true. Okay. Next, this one. We have log square root of x, x to the k. So that's gonna be, we can use the rates of change formula. So that's gonna be ln x to the k over ln square root of x. Square root of x is x to the 1/2. Now, I can move the k to the front, so that's gonna be k ln x, and I can move the 1/2 in the denominator to the front. So this is gonna be 1/2 ln x. Now, this can cancel, and I have k over 1/2. So if you multiply by 2 here and by 2 here, the numerator and denominator, you get 2k. This cancels. 2k over 1 is 2k, therefore this is 2k. So this is true. Okay, that's how you do that. Okay, next, the equations, right? Okay, let's do that here. Okay, the first one. ln x minus 3. So I need to write this as an exponential equation. So e minus 3 equals x. So that's the answer. E over 1 over e over 3 is the answer, right? So that's the answer for the first one. The second one. The second one, the same thing. There's no number here, and the log, this is assumed to be base 10. So you write as an exponential, you have 10 to 2 equals 3x minus 2. Add, this is 100 plus 2 over 3x. So that's 102, right? Equals 3x. Divide by 3, you get your answer, right? So x equals whatever that is. What is that? 20 or 30. What is that? 30, 30, 34, I believe, right? 32, 34, 12. Yeah, 34. That's the answer. Okay, 34, 34. Yeah, that's the answer for the second one. Third one. Okay, so you can write this as for the left side on number 3, you can write log x to the second power equals, since these are the same base, you can write as a quotient because you see the sum. So you can write as, I'm sorry, not quotient, the product. So you write this as 2 times 3x minus 4, right? That's what it is. So since I have the same base, I can just write x squared like the exponents. It's the same thing. So this is 6x minus 8. So now this is x squared minus 6x plus 8 equals to 0. So this is x minus 4, x minus 2, and x equals 4, and x equals 2. You can check for the extraneous solutions, okay? I'm not gonna check that. I'm trying to do fast. You know, if you put the logarithm there and it's negative, you know that that's not gonna work. 4. 4 is gonna be, so I have a sum, so I can write as a product, log x, x minus 1, right? So that's my product. And I have on the right side, I have log 4x. Now you have the same base. This is base 10, this is base 10. So I can set the parentheses equal to each other. So this is going to be x squared minus x equals 4x. X squared minus 5x equals 0. X minus 5. So x equals 0, x equals 5. Okay, that's 4. Now I'm going to erase this to go back to 5 and 6. Okay. 5. So I have a subtraction, so I can write as a quotient because they have the same base, right? This is log 3 x plus 25 over x minus 1. And this is going to be equal to 3. So if I rewrite, this is 3 to the 3 as an exponential equals x plus 25 over x minus 1. You know that this is 27 on the left side. times x minus 1 equals x plus 25. This is 27x minus 27 equals x plus 25. We move this to the right. Okay, so now I need to solve. So this is going to be 20, subtracting negative x in both sides, I get 26x. And adding 27 in both sides, I get 52. So x equals 2. Okay, so that's the answer for number 5. Number 6, let me put that in blue. 6. So you have a product, right? So, so you have a sum you can write as a product. X minus 5, x plus 3, and this is 1, right? So I can write as an exponential function. So this is 9 to the 1 equals x minus 5, x plus 3. A FOIL, x squared plus 3x minus 5x is negative 2x minus 15, and this is equal to 9. So this is going to be 0 equals x squared minus 2x. Subtract negative in both sides, negative 9 in both sides, you're going to get negative 24. And now you need to factor, right? So that's going to be 6 and 4, right? So the answer is x equals 6, x equals negative 4, right? You know, if you plug negative 4, will give you a negative logarithm, right? So if you plug negative 4 here, right, you're going to get negative 9. So you know that that cannot happen. So this is the extraneous solution, right? Okay. Now 7. 7 is log x plus log x minus 3 equals to 1. So I have the same base 10. I can write it as a product. So this is going to be x minus 3, and this is equal to 1. Write it as a exponential. So 10 to the 1 equals x squared minus 3x. Now factor x squared minus 3x. Subtract negative 10 in both sides. You get 0 here, and you get negative 10. So you continue. So x squared minus 3x minus 10, factor, right? Equals to 0. X minus 5x plus 2, right? Equals to 0. X equals 5. X equals negative 2. That's number 7, right? Yeah. And check for the extraneous solution always, right? Now 8. 8. So we have log base 2 x minus 2. So you have the same base, you have a sum. So I can write it as a product, x minus 2, x plus 1. And this is going to be 2. So you do this loop. So 2 to the 2, right? So this is x squared, you FOIL it, this one, you FOIL, yeah, okay? You FOIL. So this is going to be x squared plus x minus 2x is going to be negative x minus 2. 4 is here. I subtract negative 4 in both sides. So you know that this is 4. Subtract negative 4 in both sides. You get 0 equals x squared minus x minus 4 in both sides. That's going to be negative 6. Now factor x minus 3, x plus 2, right? So the answer is going to be x equals 3, x equals negative 2. That's it. So that was number 8. And check for the extraneous solution, right? So this is the extraneous solution, the 2. Because if you plug that here, you're gonna get negative 4, possible. Okay, extraneous solution. So this is answer. Okay, so that was number 8. Next, prove the following statements. Let me erase this thing. Okay, so here they want you to prove this thing. Okay, so here I need to prove that the left side equals to the right side. So what I'm gonna do is I'm gonna do the change of base formula. So this is gonna be log x over log, let me see what I can write. I'm gonna write it on the top, okay, because no space here. So I'm gonna use a change of base formula. So that's gonna be log x over log square root of b, right? So you know that this is log x, and then log square root of b is the same as log b to the 1/2. So you can move the 1/2 to the front, right? And at this point, if you really think about it, and in terms of the numbers, there's an invisible 1 here in front of the log. Let me write this thing. There's an invisible 1. So 1 over 1/2 is just 2. And now, if you think about in terms of these numbers, you can write that as remember the quotient of log x over log b is this is your base. So it's going to be log base b of x. So indeed, this is true, right? This is true, right? You can write this the quotient, you can write it as your denominator will be your base and your numerator will be your number. So that's true, this property. Okay, next. Here they want you to prove this, right? So again, the base of change formula, log, you know the square root of x is the same as x to the 1/2, and then that's on the numerator. And here in the denominator is going to be log. You have 1 over b. So you can say that this is, remember b is 1/2, right? So if it's the reciprocal of that, right, that would be negative 1/2, right? Because think about it. This is 1 over b to the 1/2. So if I want to put it on the top, it would be b to the negative 1/2. So this is b to the negative 1/2. Okay. Now, I'm going to move the 1/2 to the front using the power rule. And here I'm going to move the negative 1/2 to the front, right? So these will cancel and I get negative 1 here. So negative 1. And I have the quotient again. So my denominator is my base and this is my number. So that's the same as this one. Okay, next. This guy. Okay, I'm going to use the same trick. Log x squared over log b to the 4. Okay, now I'm going to move the 2 to the front. So this is 2 log x. And then here I have 4 log b, right? Now, if you think in terms of the numbers, this is going to be 1/2, right? Or I can put the 1/2 on the front like this. Now I need to simplify this. So again, this is the change of base formula, right? I'm sorry, not the change of base formula. I need to work backwards the base of change formula. So that's going to be log base b of x. Remember the 1/2 is here, right? So now I'm going to move this 1/2 here and I'm going to put it on the top, right? So that's going to be log b x to the 1/2. And you know, x to the 1/2 is the same as the square root of x. So now this is log base b square root of x. So that's the answer. So this is true. Okay. Make sure that you practice though. Giving you a lot of examples here. So this is basically chapter 4. If you know this, then you're good. I'm going to divide this into 2 parts because there's a lot to do. And the other part I will record later. Okay. So here they want you to write in terms of x, y, and z. So here I can write this as log 4 times 3, right? So that's going to be what? Or I can write this as 2 squared times 3. So this is going to be log 2 squared plus log 3. I'm going to move this to the front, right? So I'm going to get log 2 log 2 plus log 3. And you know log 3 from these definitions, right? Here, here, and here. They said that log 2 is x. So this is 2x plus log 3 is just y. Okay, so this is the answer. 2x plus y, because they want in terms of x and y, right? So that's the way you're supposed to do it. Next. Let me write it here next time. Okay. So here we have log 200. So 200 is the same as 2 times 10, 2 times 100. So this is log 2 plus log 100. So I can say log 2 is what? X from these values, right, that they give me here. And this is log 100. So log, this is base 10, 10 to the second power is 100. So I can move this using the power rule. So this is x plus 2 log, remember this is base 10 and 10, and you know base 10, 10 is 1. So remember log base 10, well, there's no 10, it's assumed to be 10. It's always 1. So in this case, I have just 2 times 1, which is going to be x plus 2. Okay, that's how you do number 2. Number 3. Number 3, I have log 4. Well, this is a quotient, right? So I can write as a difference, log 4, log 3. But I don't have 14, so I have to break it down into 7 and 2. So 7 times 2 minus log 3. So that's going to be log 7 plus log 2, right? Because you have a product, you can write it as a sum. Log 3. So log 7 is what? C. Log 2 is what? X. And then log 3 is Y. So this is the answer. Okay, make sure you practice these things. Here, we have log 0.3, right? So you can write this as what? Log 3 over 10. If you write 3 over 10, you're gonna have 2 and 5. So that's not helping, right? Because if you do log 3, you're gonna end it up with log 5 somehow. So you cannot do that. You have to find another number. So let's see what number we can use. This is a little bit, when it gets a little annoying, this thing. So let's see. Okay, let's see. So 3 over 10 doesn't work. Actually, it does. 3 over 10. Look, if you do that, you get log 3 minus log 10. Log 3 is what? Y. And log 10 is base 10, remember? Log 10, 10. So that's going to be 1. So that's the answer. Y minus 1. Okay? That's the answer. So here, we can do log 1.5 is 3 halves. So this is going to be log 3 minus log 2. You have log 3 is y, and log 2 is x. That's it. That's the answer. Next, 10.5. Log 21 over 2. That's 10.5. So this is log 21 minus log 2. You know log 21 is the same as 7 times 3 minus log 2. So log 7 plus log 3 minus log 2. Okay? And you solve for this thing. Now you have log 7. You know, log 7 is C, log 3 is Y, and log 2 is X. That's it. You're done with number, what number was that? Now this is number 6, and this was number 5. Okay? That's how you do that. Let's continue. Number 7, log 15. You might say, oh, I can do 45 over 3, but 45 over 3 is not going to help you because you're going to have the 9 and the 5. So this time that doesn't work. But if you do 60 over 4, you get log 60 minus log 4. So log 60 is the same as log 10 times 6, right? Minus log 4. Log 4 is the same as 2 to the second power. So you're going to get negative 2 log 2. And here you're going to get log 10, right? Plus log 6. Log 10 is 1. Log 6 we don't have, but I can write log 6 as log 2 times 3 minus 2 log 2 is x. We're almost done. So we can do one more expansion. Log 2, this is the product, so I can write as a sum. Log 3 minus 2x. Log 2 is x and log 3 is y. So this is going to be 1 plus x plus y minus 2x. So therefore, this is going to be negative x, or you can do 1 if you want. 1 minus x plus y, because here you need to combine like terms. this x, and this negative 2x makes this negative x. So you have 1 minus x plus y, and that's your final answer, this one right here. Okay, so that was number 7. Okay, number 8. So we need to write in terms of that, right? So this is log 6,000, or 6 times 1,000 plus, actually minus log 7. So this is the product, so I can write as some log 6 plus log 1,000 minus log 7. So log 6 is what? Log 2 times 3 plus log 1,000 is 10 to the third minus log 7. Log 2 plus log 3 plus, well, here we have, you can use a power rule here, right? Move this to the front. So this is going to be 3 log 10 minus log 7. So log 3 is x, log 3 is y. Log 10 is 1, so that's just going to be 3. Log 7 is negative c. So that's the answer, x plus y plus 3 minus c. Okay, that's how you do these problems. Next, we need to solve the equations. And I'm going to stop at the equations, and then after that, I will do part 2, will be the graphs, okay? Okay, this one. So here I have 3x. I'm going to add 2 in both sides, I get 14. So I can use the power rule, move this to the front, x ln 3 equals ln 14. Solve for x, this is ln 3. So x equals ln 14 over ln 3. Okay, that's the answer for that one, number 1. Okay. When you don't understand, pause the video and try to do it by yourself, and after that you can check what it is. Okay. Number 2. 3 to the 1 minus x to the 2, right? So there's too many ways to do this. Okay. I'm gonna use 1 minus x. I'm gonna move this to the front. Okay. So 1 minus x times ln 3 equals ln 2, right? Or let's see if you can do another way. Or you can try this. This is the same as 3 to the first times 3 to the negative x. So if I add the exponents, I get this the same as that, but I can break them down, right? So this is going to be 2 on the other side. So I can say that this is what? I can divide by 3. So I get 3 negative x equals 2/3, right? So if I use the logarithm, I can say this is negative x ln 3 equals ln 2/3, right? And then I need to divide by negative ln 3. So x equals ln 2/3 over negative ln 3, right? And that would be your answer for this problem, since you don't have calculator here. Okay? You can do that. That was number 2, by the way. Next. Number 3. Number 3, they have this. 4 to the x equals 5x plus 1. So you can write 4 to the x equals 5 to the x, 5 to the first. So I'm going to put the x's together. So that means I'm going to divide by 5x here in both sides. So this cancels out. I get 5 equals, I'm going to rewrite this 4 over 5 to the x power, and I'm going to use the logarithm concept on the power rule. So this is x ln 4 over 5 equals ln 5. Now divide both sides by ln 4 over 5. So x equals ln 5 over ln 4 over 5. And that's the answer, right? Since we don't have calculator. So that was number 3. Okay. Let's try to do number 4. Okay, number 4. 6 to the 1 times 6 to the negative x equals 10 to the x. Again, divide by negative 6x in both sides. So that means this cancels out. I get 6. This is 10 to the x times 6 to the positive x, because if I move the negative, the denominator to the top, it would be positive, right? Now I can say this is 10 times 6, which is 60 to the x equals 6, right? And yeah, so you can use the logarithm now. X ln 60 notice that I'm not adding the powers. I combine them. That's all I did. So this is ln 6. So ln 60 over ln 60, right? And then you get your answer. So that cancels out. So you get x ln 6 over ln 60. Okay, that's the answer. Next problem. Let me put that in 2. So here you have 5. You have this this problem. So here I'm gonna do 2x plus 1 ln 3, right? I'm using the power rule, and then I have x minus 2 ln 2. Okay. Now I'm gonna distribute this. So this is 2x ln 3 plus ln 3. This times this, right? This times the distributive property, and then x ln 2 minus 2 ln 2. Now I'm gonna put the x's with the x's, and I'm gonna put the x's with the x's. I'm gonna put this together and this together. Okay. So if I do that, I get 2x ln 3 minus x ln 2 equals negative what is that here? Yeah, it's gonna be negative ln 3 minus 2 ln 2. Okay, so if I factor the x here, I get 2 ln 3 minus ln 2, and I have here negative ln 3, right? Minus ln 3 minus 2 ln 2, minus ln 3 minus 2 ln 2. Now you need to solve for x, right? So that means you need to divide by 2 ln 3 here minus 2 ln 2, and you do the same here, 2 ln 3 minus ln 2. This cancels out. You get x equals, now you got negative ln 3. You can write this as, well, we can factor that negative if you want. So that's going to be negative ln 3 minus, well, I can write this 2 goes on the top as ln 2 to the 2, which means that this is going to be what? This is going to be well, if I factor that negative, right, that's going to be negative, and this is going to be positive, right? And then I can use the reverse power rule and put this constant as an exponent. So that's going to be here, and then you have 2 ln 3 minus L2 minus ln 2. Therefore, this I can say, well, this is 4, right? So this is going to be 4 now. And because it's 4, I can multiply these two, because a sum I can write as a power. So this is going to be ln 12 over the denominator, whatever that is. 2, let me make it smaller a little bit so everything fits. Okay, so divided by 2 ln 3 minus ln 2. So that's the final answer for number 5. Okay, if you can do these problems, then you should be okay, right? You should be okay for that test, whatever they throw you at. Next, 6. 6, we have these, so I'm gonna cross multiply, okay? So this is gonna be 10 equals 2, 1 plus e to the negative x. So divide by 2, I get 5, right? 1 plus e to the negative x, subtract negative 1, I get 4, e to the negative x. take ln in both sides, so ln 4, ln of e is just negative x because I can use the power rule, so this is going to be negative x, ln e. You know by definition, ln e is what? 1, right? So that disappears, and then you divide both sides by negative 1, and you get negative ln of 4. That's 6. 7. 7, you have, okay, so you're going to use this a equals 5 to the x. If you square that, you get 5 to the x to the second power. So that's going to be a squared equals 5 2x. Now you can substitute this, right? For number 7. So number 7, they said 5 to the 2x, that's going to be a squared. 5x is just a, and negative 12 is just negative 12 equals 0. Factor a minus 6, a, actually no, 4 and 3, right? 4 and 3. So negative 4 times positive 3 is negative 12, negative 4a, and positive 3a gives you the middle term, negative a, and a times a is a squared. So now you set it equal to 0, you get a equals 4, a equals negative 3, and now you need to replace back. So a was 5 to the x equals 4. You have to take the ln, right? So this moves to the front. X ln 5 equals ln 4, divide by ln 5 both sides, and that's your answer, right? So this cancels, so x equals ln 4 over ln 5. That's one answer. And the second answer, we have 5 to the x equals negative 3. So this is going to be undefined, and I will show you, because if you move this to the front, you get x ln 5, and here we have ln negative 3. You cannot have ln negative, so this is undefined. Okay, be careful when you're solving this extraneous solution, this kind of stuff. Okay, let me do one graph or two, and then after that I will stop here. Then after that I record the rest after, because then after that we have some inverse and some other stuff. I will do that later. So here, the first one, draw each of the following functions and analyze each of them. So very easy. Here you have f of x equals log x. That's the basic function. So you know that these logarithm have vertical asymptotes. So the first thing you should do is set this parenthesis equal to 0. So this is the vertical asymptote, x equals 0, right? So that means you can draw your dotted line here at 0. And then what else you need to find? Well, plug points, right? So x, y, plug 1, you know log of 1 is 0. And then you can plug, this is base 10, so just plug 10, right? So 10, log base 10 of 10 is 1. So 1, 0 is here. And then you have 10, 1 is here, about here somewhere. So if you graph this, it should be something like this, right? Something like this. What is the domain? The domain is from 0 to infinity. Well, you can set up the parentheses greater than 0. So anything greater than 0, right? So from 0 to infinity, not including 0. And the range is from negative infinity to infinity. That's it. That's how you do that. That's all you have to do, right? For this problem. Number 2. That was number 1, by the way. Number 2 is asking you to graph this function. So we have f of x equals log negative x. So this is a reflection over the y-axis, right? You will see. So I need to set up the parentheses equal to 0, so the asymptote is at 0 anyway. Okay, and then we know that the inside has to be greater than 0 by definition. So if we divide by negative, that flip the inequality. So all the numbers less than 0 is a domain. That means there's a flip over the y-axis, right? Now you need to plug points, x and y. So plug negative 1, because negative of negative 1, that will be 1. So log of 1 is 0. And then you can plug negative 10, right? So negative 10 equals 10. Log 10 equals 1. So negative 1, 0 here. And then negative 10, 1 is about here somewhere. So This is a reflection about the y-axis. Okay, so what is the domain? We said that already. It's from negative infinity to 0, not including 0, and the range is all real numbers, from negative infinity to infinity. Okay, that's it. Okay. That's how you do that. Let me do one more about how you're supposed to do that, and I will do the inverse as well, so I don't need to do all the problems here. Okay, because the inverse is the same as this one. Okay, so I'm just gonna do 3, and then after that I will stop here, because then that's basically that chapter. So here you have f of x equals negative log x minus 3, right? So if they want you to find, this is a reflection over the x-axis when you have a negative on the front. So basically you have this. So first find the vertical asymptote. The vertical asymptote of the logarithm here is the parenthesis equal to 0. X minus 3 equals 0, solve for x. X equals 3. That's a vertical asymptote. 1, 2, 3. Right? That's a reflection over the x-axis, and it's a translation 3 units to the right, right? This means translation x units to 3 units to the right, right? And this means reflection over the x-axis. Okay. Now I need to plug values, right? So let me plug some values: x, y. So let's pick 4. 4 minus 3 is 1. Log of 1 is 0. Times the negative is 0 anyway. And then we can find 13. 13 minus 3 is 10. Log base 10 of 10 is 1. Times the negative 1 is going to be negative 1. So it's going to be 40. That's 1 point here. And then 13 comma negative 1, that's about here. So that's the reason it was a reflection over the x-axis. Sorry, over the y-axis. So over the x-axis, I'm sorry. This one is over the, what is that? This is over the y-axis. This one is over the x-axis. So now you just need to plug it in, right? So this is supposed to be like this. Okay, that's that graph. That's how you do that one. Okay. Now, if they want you to find, oh, the domain, right? The domain is what? The domain is from negative, from 3, right? Because remember, this x minus 3 had to be greater than 0 at 3 in both sides. So x equals 3. So from 3, not include 3 to infinity, and the range is all real numbers. Now, if you need to find the inverse of this, let's say that they want you to find the inverse. So the inverse of this guy. So you have f of x equals negative log x minus 3. You need to switch. First, make f of x as y. Remember, f of x is the same as y. So this is going to be negative log x minus 3. Now switch the positions with y and x. So this is going to be x equals negative log y minus 3. Now you need to solve for this, right? So you can write this as an exponential function now, because that's the goal, right? Write it as an exponential function. Let me move this around. So you have this is base 10, right? So I can say 10 to the x. You can subtract if you want here, if you want. Negative here, negative x equals log base 10, right? Y minus 3. Now you need to write as an exponential function. So this is going to be 10 minus x. Right? So 10, you do the loop, right? So 10 to the negative x equals y minus 3. And now you need to add 3 in both sides. And that's basically, so add 3 in both sides. So this is 10 to the negative x plus 3 equals y. Remember, y is the inverse. This is 10 minus x plus 3, right? So that function that you just found is the inverse of the original function given, right? The negative log x minus 3. So this is 10. to the negative x plus 3. So this is the inverse function. Okay, this one right here. So if you graph that, the inverse function, this is 10 negative x plus 3. So you can do you can just plug points, right? And you find whatever that is. Some professors, they want you to write this as this, and then you know that this is what decay, right? You can do that as well if you want. But whatever is easier, whatever works for you, you have to be able to identify that that's a decay, even though it wasn't written in the inverse function like that, right? So anyway, let's do that. So plug points, right? So let's plug 0. Any number to the 0 is always 1, right? And 1 plus 3 is 4. Now we can plug -1, right? If we plug -1, we get positive 10, and that's 13, right? So if you graph this, what is the original function? So if we plug 0, right? For this one, we get any number to the 0 is 1, and 1 plus 1, yeah, we get 0 here, right? If we plug here is 10 to the 0 plus 3. So this is 1 plus 3 is 4. And then if we do the other one, right? If we do the -1 and the 13, -1 will be 10, -1 plus 13. Actually, plus 3, I'm sorry. Plus 3. So that's going to be 10 to the first plus 3. So that's 13, right? Just showing you how I get it. And the first point, remember, this is an exponential, so it has a horizontal asymptote at 3, right? And what else? So the first point is 0, 4. So 0, 4, that will be here. And then the second point is -1, 13. So you can assume it's somewhere around there. And you can see why it's decay, right? So if you plug these together, let me see if I can do that. Can you bring this? It's above here somewhere. So they will be symmetric about, I mean, it will be a reflection over the line y equals x, something like this. Sorry, this is not perfect, but that's the point. Okay, it will be somewhere, something like that. Okay, something like that. Okay, you can play around with that thing, and notice that the values are the inverse of both, right? So you have to be able to analyze the situation. The values are you see how they switch places, and then you can figure it out depending on what kind of function or what kind of transformation you're doing, right? So that's it. Okay, so that's how you do it. Okay, so let's do one more inverse function from here, from this set. Here we have f of x. Find the inverse function of this. Let's do just one, okay? Because I think you guys understand. So this, I'm gonna change f of x to y. This is log base 2, x minus 3 minus 5. So I need to switch x with y at 5 in both sides. Now I can do I can write this as an exponential function. Let's see, 1 second. X plus 5. So I can write this as an exponential function like this. 2x plus 5 equals y minus 3. Add y in both sides. I'm sorry, add 3 in both sides. And you get this. The inverse function of this is this. And now you can graph that, right? So now you have the logarithm function and the exponential function. And you put that in yellow. Now graph it, right? let's do the graphs. So log 2x minus 3, right? So you know that this is gonna be, it has the logarithms, they have vertical asymptotes, and the exponentials, they have horizontal asymptotes. So this is basically what's going on. So we need to plot values here. The vertical asymptote, these are translation 3 units to the right. 1, 2, 3. So we put the vertical asymptote here. So this is the vertical asymptote is y, x equals 3, I'm sorry. And we need to plug values here. So let's plug 4. 4 minus 3 is 1. Log base 2 of 1 is 0, minus 5 is minus 5. And then we can plug, let's say it's 5. We plug 5, that's going to be 2. Log base 2 of 2 is 1. 1 minus 5 is negative 4. Okay, so that's going to be 4 here and negative 5 somewhere here, right? And then the next part is 5 comma negative 4. So 5 negative 4, that's about here somewhere. So you can see the behavior of that, right? That's what's happening here. So you have something like this, right? Now, the other one, the inverse, is asking for these values, right? So, and you know that the domain here is what? The domain is from 3 to infinity, and the range is all real numbers, right? For the logarithm. And then for this one, we can use values to, let's see what we can use. If it's negative 5, right? If we put negative 5, that's going to be 0. Number to the 0 is 1, plus 3 is 4. So notice is the reverse of the ones that I have on here, right? And then if we use, let's say, what value we can use? We need to get nice numbers. So if I want to get, let's say 1, if x equals negative 4, that's 2 to the 1, and 2 to the 1 is 2 plus 3 is 5. So negative 5, comma 4. So negative 5, because this is the inverse function. So negative 5, comma 4. So negative 5, 1, 2, 3, 4, 5, comma 4. So 1, 2, 3, 4. It's about here. And then the other one is negative 4, comma 5. Negative 4, comma 5. Negative 4, comma 5. It's about here. And remember, this has a horizontal asymptote of y equals 3, right? Because remember, this is the vertical asymptote, the horizontal asymptote. So this is y equals 3. So y equals 3 is about here. Okay? And that's your graph. This is exponential growth because look at the a value, right? A to the x plus 5. This guy is the growth or decay. If a is greater than 1, it's growth, right? And if a is between 0 and 1, is decay. So in this case, it's growth. Something like that, right? And they should be symmetric about the line y equals x, right? So that's it. I show you how to find the inverse. I show you how to I show you how to find the inverse. I show you how to graph the logarithms, the exponential functions. I show you how to prove if the left side equals the right side. I show you how to make exponential equation into logarithm equation and logarithmic equation into a exponential and vice versa. I show you also how to I show you how to expand, compress properties of logarithms. And let's do one problem before we leave. Just one of these. I keep saying I'm gonna leave and I don't leave, right? Okay, let's see. This is the last one. $15,000 is invested into an account that yields a 5% interest rate per year. After how many years will the account worth this if the interest is compound yearly? Okay, so the formula for compound equals And the amount, the principal, okay, the amount equals the principal plus 1 plus the rate over n times nt, right? So P is the principal, so the money that you put at first. A is the future value or the amount, right? Sometimes they call this a future value, right? The principal is the present value. R is the rate. N is the number of compounds per year, right? Sometimes you compound 2 times per year, or you semi-annually, annually, you compound quarterly, monthly, depending on situation, right? And T is time, right? So you should know how to do that. So 15 is invested. So the original amount is $15,000, right? 1 plus the rate. The rate is a yield. If 15,000 is invested in an account that will pay 5% interest rate, so this is 0.05, right? You have to make that percentage into a decimal, right? Divide by 100 and you make it into 0.05. After how many years will the account be worth this amount? So they're giving you an amount here that they want to make it. I think it's 91,000. That will make sense. 91,221 and 04 cents. If it's compound yearly, so the number of compounds is just 1, right? So that makes sense because usually banks or whatever financial institutions, they give you the interest rate annually and the number of compounds. And N is 1, right? And T, they're asking you how long, right? After how many years? So you need to find T. First thing is you need to divide 15,000 by 91,000, whatever that is, right? So divide both sides by 15,000. So you should get 91,000 to 1.04. You get divided by 15,000. You should get 6.08. Let's keep 4 decimal places. And we have left 1 plus 0.05 to the T, right? So at this point, I can add these together, right? Inside 1.05 to the T equals 6.0814. And the only thing I need to do is the logarithm now. So ln 6.0814 equals T ln 1.05 divided by ln 1.05, both sides. This is equal to ln 6.0814 divided by ln 1.05, and you get 36.9. So you can round it to the nearest year, so 37 years it will take, right? Because it's only paying 5% and it compounds yearly. So that's the reason it takes it takes a lot of time for you to reach only like about the difference between these two values, right? The future value and the present value. So it's about $5,709, right? So it takes time because I'm sorry, it takes time for you to get, because I was looking at problem 14. I'm sorry. It takes some time because it only compounds. Okay, how many years? What's the compound here? Yeah, the number of compounds is per year, right? So here they're asking you per year. So it will take some time. It takes 37 years actually to get into 91,000, because if it compounds, like let's say semi-annually, quarterly, or monthly, then you will get that money faster. But usually in real life, it's not like that. Usually financial institutions, they compound yearly. Okay. Okay, so number 1 is the same as number 2, right? Yep. I will do these problems later. And that's the end of this worksheet, by the way. Okay. So there's not much to do. I show you everything basically. Okay. Don't worry too much about some of these problems, but worry about more about graphing,
solving the equations, prove the equations, and that basically. Have a nice day.